In the long run, firms enter an industry if they believe they can make positive economic profits. That means they believe that they will earn more profit than they could earn with those same resources doing anything else at all. Economic profits mean that this business opportunity beats all other business opportunities available. This quest for positive economic profits will steer resources towards high-value uses. Let's graph some of the costs we've been talking about in this chapter. On this graph, price is on the vertical axis, by which I mean the dollar value of each cost we mention, and quantity produced is on the horizontal axis. We can start by graphing marginal cost. Due to diminishing marginal returns and rising opportunity costs, the marginal cost curve usually looks like this. Initially, the marginal cost of production probably drops as a firm takes advantage of minor returns to scale and various cost-cutting measures that come with mass production. But eventually, those marginal costs rise as quantity increases. Average costs include our fixed costs, so they start a bit higher than marginal cost. But if marginal cost is below average cost must be falling. And once marginal cost rises above average cost starts to rise. Marginal revenue will be a flat line equal to the price we're able to sell our product for. So, how much will firms produce? Remember our profit maximizing rule? Where is it on this graph? Seriously, I'm going to go full Dora the Explorer right now. Can you spot the profit maximizing rule? Point to the spot on this graph that satisfies the profit maximizing rule. I'll wait. Yes, good, it's here, where marginal revenue is equal to marginal cost. At this point, the marginal cost is the same as the marginal revenue. We can even put some numbers in here to make it concrete. Let's say this is 60,000 units of the good. At this point, the firm is producing 60,000 units. The marginal cost of producing one more is 50 cents. And that's also the marginal revenue, or the price we can sell each unit for. Now look at the graph and tell me how much of this is profit. Can you tell? We can. The average cost at 60,000 units is way below 50 cents. Let's say it's 30 cents. That means on average, it costs us 30 cents to make each one of the 60,000 units. And that is including fixed costs and everything. This firm is selling 60,000 units for 50 cents each. It costs 30 cents on average to produce one unit. The profit for this firm is 60,000 times 50 cents minus 30 cents, which is $12,000. That means this firm is making $12,000 more than other firms which use the same resources. Other firms have the same labor and capital and access to raw materials, but they're making less money. So what are they going to do? Positive economic profits are like blood in the water. They attract sharks. They attract firms to this business because there's more money to be made here than elsewhere. What happens when competition comes in? We haven't proven this, but intuitively, I think you'll know that more competition means lower prices. As firms enter this industry, they will push the market price down, and that will eat into these profits until finally they drive the price down to be equal to average cost at the profit maximizing quantity. When this is the case, economic profits are zero. Each firm is earning zero economic profits. They still have accounting profits, they still want to stay in business, but they aren't making more money compared to similar alternatives. And of course, if the price dropped further, firms would earn negative economic profits, and firms would start to exit the industry until the price lifted high enough to support what firms remain. This leads us to the zero profit condition. In a competitive environment, economic profits are competed away, all the way to zero. What do I mean by a competitive environment? 1, sellers have access to all information about the best production methods. We will talk about what happens when firms have patents or other advantages, but for now, we assume every firm knows how to minimize the costs of production. We call this perfect information. Second, there are low barriers to entry, allowing new firms to start up easily or shut down easily. We call this free entry and exit. Basically, it has to be possible for new firms to enter an industry with high profits or exit one with low profits. If that is the case, then we expect competition to force prices down until this business opportunity looks just as enticing as any other. When we think about business, we tend to think about how profits are good. But they're only good for the business owner. They're bad for consumers who pay too much for a product that could be cheaper. The zero profit condition is an outcome we want to see. We want to see competition drive prices down and make industries more efficient by lowering their average costs. And the more you think about it, the more obvious the zero profit condition will be. If there are profits to be made, someone is going to try and get them. And the more competition those profits attract, the smaller those profits will get. This doesn't mean that every industry will have lots and lots of firms competing in it. Different industries face different long-run average costs. Decreasing cost industries are industries where costs decrease as quantity increases due to technologies that can be employed at a large scale. Having a small car company means your cars will be very expensive to make because you'll need to do a lot by hand. But if you scale up to producing millions of cars, it becomes feasible to have a giant automated factory which produces cars cheaper on average. We call this increasing returns to scale. For these sorts of industries, we would expect a few big firms. Constant cost industries are ones where the costs don't change much as we scale up. Customer service has fairly constant costs. As you scale up, you need roughly the same inputs, and there aren't any increasing returns to scale. Instead, you get constant returns to scale. Increasing cost industries are ones where costs increase with output due to increasing opportunity costs. Landscapers probably face increasing costs with output. As you scale up, you need to add lots of supporting infrastructure like a call center to schedule service, managers to monitor different teams, and all the rest. That's why most landscapers are just a few employees all working from the same truck and handling their own schedule. Here you get decreasing returns to scale. Thinking about this long-run cost curve can help us think about the size of an industry. Most manufacturing businesses probably face a long-run average cost curve that looks like this. They start out producing a small number of units expensively, but if they see some success, they can scale up and take advantage of increasing returns to scale that come with mass manufacturing. But eventually they probably reach a valley where their average cost per unit flattens and they face constant costs for a while. If they get big enough though, they might struggle to get more of the raw materials they need and organization costs start to go up, leading to decreasing returns to scale as average costs rise. Apple has started to reach this point with production of the iPhone. They make so many that their chief limit on advances are getting enough of the raw materials they need to make as many phones as they do. In the curve drawn, we can see that average cost, bottoms out at 5,000 units and stays that low to 50,000 units. If there's demand for 500,000 units of this product, then there would be room for 10 to 100 firms to be producing this product. You could have 10 firms all producing 50,000 units, or 100 producing 5,000 units each, or something in between. That's because firms which reach this minimum average cost will outcompete any firms producing on the edges, where they face higher average costs and therefore lower profits. When you take all of this together, you have a theory of the firm which predicts when firms will form and how many will try to move into each industry.